So in the last class, we primarily focused on the other presentation to install this one, to install Cloudera Manager and Cloudera Distribution of Hadoop first. And then we started working on setting up the Hadoop core components. And in that, we have seen the Hadoop architecture, especially for HDFS. We have seen HDFS architecture. We have spoken about data nodes in detail and name node in detail, but we haven't spoke about secondary name in detail. We will see that today. And we have seen the parameter files, core site.xml and HDFS.xml briefly. And also we have seen name node web UI. We haven't seen data node web UI yet. We will see it today. And also we will look into the log files today with respect to HDFS. Okay, and so as I mentioned to you earlier, when we actually copy a file, let's say you have a 16-node cluster and you copy a 2 GB file, and there are two important parameters called as block size and replication factor. And block size is used to distribute the file into blocks and then copy to multiple nodes in the cluster. And the replication factor is to improve the fault tolerance and resiliency of the data. And the mapping between the file name, which is logical, and the block names and block locations are maintained in name nodes in memory. And as Chintan have asked, what happens when name node goes down? Memory is transient. If the name node goes down and if there is no mechanism to restore name nodes, then you will not be able to bring back your file system in HDFS. To support that, there are two components, edit logs and FS image. So I will start about these things now, and then we will talk about secondary name nodes, and then we will talk about important configuration parameters, and then we will even talk about high availability configuration of HDFS. Okay, so let me go on to whiteboard. So we have a 16-node cluster, and we have this name node, and we have 16 data nodes. So on like that, you have 16. Okay. Let's say take the hypothetical number. Actually, we have 10 data nodes, so let's assume that we have only 10. Okay, let me draw 10 here. So we have 10 data nodes and one name node. And when we actually copy a 2 GB file, what happened is it is divided into 16 blocks because our block size is 128 MB. So it will result into 16 blocks. And the naming convention is like this, BLK underscore very large number. And let's assume that first block is 1. Like that, as it is more than 2 GB, it created 17 blocks we have seen in the last class. So starting from 1, you will see up to 17. So those will be, these are the names of the physical, the blocks that are saved physically on all the data nodes. So and we have 10 nodes in the cluster. If the replication factor is 1, approximately there will be 2 blocks associated with that file on all the nodes in the cluster. And if one of the nodes goes down, then you will not be able to access most of the data. So it means that your cluster will be impacted. To overcome that, they have introduced a concept called replication factor, which by default it is 3. So each of these blocks from 1 to 17, there will be 3 copies. And those 3 copies will be stored on multiple nodes in the cluster. And this is very important point. If we have only 2 nodes in the cluster, in a development cluster, and if the replication factor is 3, still what it will do is it will only create 2 copies. And then when you actually run the command HDFS SSTK, it will say that there are files which are under-replicated. It is very important to understand that. Only if you have nodes more than your replication factor, then the files will be maintained with those many copies. The blocks will be maintained with those many copies. If your cluster size is, if the number of data nodes in your cluster are less than replication factor, for example, by default, if the replication factor is 3, and if you have only 2 nodes in the cluster, then there will be only 2 copies of each block. And then when you run HDFS SSTK command, it will show it as under-replicated. Okay, it can be a trick question in the certification. Otherwise, it is not very important. Okay. So that is about replication factor, and by default it is 3, as we have 10 nodes in the cluster. For each of the blocks in this of these 17, there will be 3 copies, and they will be copied in all these nodes in the cluster. And then the mapping between the file name, let's the file name is deck.txt. So the mapping between the file name, this block names, and the block locations, the mapping will be stored in the name node. Okay, so now whenever a file is copied into HDFS, the metadata in name node will be updated. Okay, as during that, now I'm getting into FS image and edit log, so listen to it. It is very important. When the metadata in memory, which is in memory, is updated, at the same time it will make the entry into edit log. Okay, so for all the changes that are going through name node, when the name node metadata will change, whenever there is a file added to the HDFS or file removed from the HDFS, or if the permissions are changed on the HDFS, on the files in HDFS, then the metadata will change. So in all those scenarios, whenever this name node in memory metadata is changed, the entries will be logged into files called edit logs. And then as we are capturing all the changes, these edit logs can become overwhelming. So there might be too many entries in the edit log. And if there is a scenario where we have to recover, to apply all these edit logs will take can take enormous amount of time. So to address that, what they have done is they have created another file structure. So name node is typically in memory, okay, and edit log is a file structure. On top of edit log, there is another file structure called FS image. Okay, so what FS image is? There is something called checkpoint on the edit logs. So whenever the checkpoint happens on the edit log, it will take the previous copy of the FS image and the latest entries in the edit log, and it will create a new FS image. So FS image is kind of a snapshot of your name node in memory metadata, and edit log is the delta of the last snapshot. So if you are from Oracle background, it is similar to the redo logs and the backup. So you will take backup every week, and then you will keep on accumulating redo logs for that week. And if you have to, if your database crashes, and if you have to bring up your database, first you will take the last backup, restore it, and then you will apply the redo logs. That's how you will restore your database, restore and recover your database. Similar is the technology here. So FS image is like your backup copy, and edit log is like your redo log. So if we have to recover the name node, first we will restore the FS image, and then we will apply the edit log on top of that to come to the point when the name node is crashed. So these two file structures can help you to recover your in-memory metadata of your name node. Okay. So any questions here about edit logs and FS image? It is very important concept. Okay, I will explain again. So are you clear that name node metadata is stored in memory, and if name node goes down, then you will not be able to recover your name node. All the metadata will be gone, so you will not be able to we will not be able to support the file system. So as memory is transient, it is the case. So in those scenarios when name node crashes, to restore and recovery, they introduced the two file structures. So name node is in memory, and edit log and file FS image are file structures. Okay, if your name node goes down, to build your in-memory metadata, you need to have some the data logged in at some place. Okay, so those, to support that, they have introduced two file structures. One is called as edit log, and second one is FS image. Okay, now let me do some more. Let me get into more detail. So let's say this is your name node. Forget about your data nodes for now. So let's say this is in memory. Okay, this is in memory. Okay, you just created HDFS. There is no data at all in your file system. Now you created this. Let's say your cluster capacity. First, talk about cluster capacity. You have 10 data nodes in the cluster. Okay, and the block size is 128 MB. Replication factor is 3. Okay, now you copied a file called deck.txt, which is 2 GB. So the size of the file is 2 plus GB. So let's say it has 17 blocks. And as replication factor is 3, from these 17 blocks, there will be 3 copies made into it. So when you actually copy this deck.txt into HDFS, the mapping between the file, which is logical, and the block IDs and the block locations on which data nodes it is stored, the mapping will be stored in memory. Okay, so let's say deck.txt. Yeah, there will be 51 rows in name node. For block 1, location is let's say data node D1, D2, and D3. Similarly, for block 2, it might be D2, D4, and D5. So on, there will be 51 entries. That is right. Okay. So whenever it updates the name node in memory metadata, at the same time, the same 51 entries will be made to a file system called file structure. This is a file structure called edit log. So if you try to look about your in-memory details, you will not be able to see that in your cluster because it's in memory. But if you want to look at this edit log, you can go to your name node. So let me go to the cluster. Okay, and if you click on home, and if you click on HDFS, okay, and you can click on name node. There is one name node, and 502 is our name node. So let me log to 502. Okay, Hadoop 20. You can also log into 502 if you want. Okay, and this is we are on name node now. Okay, and if you click on configuration of our name node and click on service configuration, there are parameters which will tell you where you should store these edit logs and SS image, which I am explaining. Okay, this edit log. And there are parameters which will control that. So this is the parameter dfs.namenode.name.dir or dfs.name.dir. This is old name. This is the new name convention. So you need to. It's pretty. It is intuitive. So this is the location where we will find that edit log. Okay, and if you go to that location dfs.nn. And when you do LSLTR, it will be a little bit complicated directory structure. What you can do is you can do find dot dot means current directory. So in the current directory, I'm trying to search for all the files by name. That's why I'm giving minus name, and then star to search the files. And you can see these files. Okay. So if you want so if you see, there are two files here, edit log and FS image. Okay. And if you see, there are more edit logs and very few FS images. Okay. The reason why you will find edit log, more edit logs here. So all these 51 entries will make into edit log. Okay. So let's say at T1, you copied this file. So at time T1, you copied this file. The entries are made into in memory. At the same time, actually the operation is successful only when the same metadata is updated in edit log as well. Because unless it records into file, you will not be able to recover it once if node goes down. So when we actually copy files or do any operation that updates the metadata in memory, it has to do the operation in the edit log also. So edit log, as the name suggests, log, it logs all the details that are going, all the operations that are going on in memory. Okay. So this edit log also will have 51 entries. Okay. Then let's say you have only one edit log. What the behavior of edit log is, whether it is if the file is deleted, so all the 51 entries will be gone from the in memory. In the edit log, there will be 51 entries which say there will be 51 entries in one edit log. There are a couple of parameters which control the size as well as the time. So we will get into those details later. Okay. For now, at T1 there are, let's say, 51 entries, which says that it will be inserts typically, because we created the file at T1, and at T1 there will be 51 entries here. Let's say at T2 you deleted the file, and again at T3 you inserted the same file. So if you think about in memory, there will be only 51 entries, because it will clean out from the memory, and when you actually reload the file, the in memory will have only the current status of the file. Whereas in the edit log, there will be 51 entries for the inserts, there will be 51 entries for the deletes, marking that okay, these are deleted, and then there will be again 51 so all the operations that are being done in memory will be logged here. The reason why it that is, if the name node goes down, it's a standard terminology called restore and recovery. As part of the recovery, you will apply these things, the inserts of those 51 entries, the deletes of those 51 entries, and the inserts of those 51 entries. You will apply those things in the sequence fashion. That is called as recovery. Yeah, it's a standard terminology in the database. So if you see, actually your edit log size can become overwhelming when it compares to your name node in memory, because there will be too many files deleted. Over time, there will be files added, permissions will be changed. So there will be many transactions that will be happening in the metadata. And if we just use edit log, this edit log can be 4 or 5 times larger than name node over time. Okay. So if name node goes down, if we have to use this edit log to recovery after few months, then it might take few hours to get it recovered. Okay. So as this can become overkill for the recovery process, they have introduced the second file structure, which is called as FS image. Okay. So what FS image will do is, so at T1, now again start at T1. At T1, you have created the file. Okay. So your edit log will have 51 inserts, this one, and your name node also will have 51 entries. Okay. Let's say at T2, before the delete happens, let's say T1.5. Okay. And let's say there is 1 hour gap between T1 and T1.5, and let's say checkpoint happens. So when the checkpoint happens, what will happen is this 51 inserts, which is in edit log, will be translated into FS image, which will represent your name node snapshot, because at t1.5 there is only one file. So your FS image also will have details related to that file. So it will have the 51 inserts. Okay. Now at t1.5, after the checkpoint is done, what will happen is from the edit log, this will be gone. There will be a new edit log created, and there will be nothing in the edit log after the snapshot is created. Okay. Now at T2 file is, let's say the file is deleted. When the file is deleted, there will be 51 entries in the edit log saying that file is deleted, and there will be nothing in memory because there is no files except this file, and we deleted it, so there will be no entries in the in your name node in memory. Okay. Now let's say your name node crashed, and you want to bring up to the current point. So first we do something called restore. As part of the restore, so this FS image is kind of a snapshot of the last snapshot after the last checkpoint. So the copying data from edit log into FS image is called checkpoint. So FS image represents the snapshot of last checkpoint. First, this one will be used to restore. So all the 51 entries will be made into the memory. And then when you actually apply the edit log, which is called as recovery, those 51 entries will be deleted from the file. So your name node will not have anything. Okay. So that is when there is nothing in that. Now let's say the name node is not crashed, and now if you go back, FS image have 51 inserts, and after T2 edit log have 51 deletes. Okay. Now again, let's say checkpoint happened with name. There is nothing happened to name node, and let's say there is a checkpoint happened because between T2 and T3 there is more than 1 hour gap. I will explain why I am talking about 1 hour for these checkpoints in a moment. But let's say there is 1 hour gap and there is another checkpoint happened. So when the checkpoint happened, what will happen is as part of the checkpoint, this FS image will be merged with the changes that are done in edit log. So FS image have 51 inserts on file deck.txt, and edit log have 51 deletes on file deck.txt. So now there will be a new FS image. Okay. And it will first, so by merging these two, there will be nothing in this. So FS image will be clean slate because it represents the snapshot of that point in time of name node because of the merge happened between the previous FS image and the latest edit log as part of the checkpoint. So it will be empty. Okay. Now if you copy the file, what will happen? Again, this one also, the edit log will not be having anything because it's already merged. Now there will be new edit log created, and now again, if you copy the file, your name node will have 51 entries, your edit log will have 51 entries, and your FS image will be empty until the next checkpoint happens. So the purpose of FS image is to restrict the size of the edit log file so that our restore and recovery process happens as fast as possible. So copying the previous snapshot of the name node in memory metadata, which is the FS image, is called as restore. And then this happens only at regular intervals, regular and frequent intervals. It will not happen every second. It only happens once in a while. So you will copy the last copy of FS image into name node, and to come to the point in time when the name node crashed, you have to apply the changes that are in the latest edit log, which is not checkpointed yet. So that's how you will be able to recover your name node. And if you look at the files, here you will see in the name node in the name node directory, you will see the edit logs and FS image. Typically, you will see either two FS images like this, or 3 FS images at max, which will represent only current and previous versions. But you will see many edit logs over time, depending upon the number of transactions or number of files that are copied to HDFS. So is it clear, edit logs and FS image? So again, so it just merges whatever is there in the previous edit log. Okay, so you need to forget about deleting or inserting. I just use those terms to explain. But what you need to understand is whenever checkpoint happens, the last copy of FS image. Actually, one FS image is good enough. The only reason why they create two FS images is, let's say your latest FS image is corrupted. Okay, still you can go back to the previous copy of FS image, and if you see the edit logs will be saved for quite some time, 3 days, 4 days, or whatever. It figures out how long it should save the edit logs. So even if your latest FS image is corrupted, you can go back to the previous copy and you can apply edit logs from that point in time, because you will have multiple versions. So even in the backup and recovery scenario, you can use the last copy of backup or even the previous copy of backup. So it uses, I think it keeps 2 or 3 files behind the scenes. Probably there might be some parameters also to control how many FS images needs to be retained. But the purpose of retaining more than one FS image is, if the latest one is corrupted, still you can go back to the previous one and you can apply the edit logs from that point in time. So, for example, when you actually try to restore and recovery, if this is the current version, I think, and this is the previous version. By seeing the name, this is 593 and this is 600. So let's say 600 is corrupted, you can still restore using 593, and whatever edit logs that are required from 593, they will be used to recover. So let's say if you have 10 edit logs from 593, all the 10 edit logs will be applied. But after 600, if it uses 600 for the restore, and if there are only 3 edit logs, only those 3 edit logs will be used to recover. Okay, and MD5 is it's a checksum. So the purpose of these MD5 files are to validate whether your files are corrupted or not. Okay, it is a standard algorithm to compute the checksum. So it will go through the contents of the file and it will compute the checksum. And using checksum, it will determine whether the file is corrupted or not. Okay, so you can so whenever a file is created, in tandem a checksum file also will be created, and when you try to read the file in Hadoop also in general, the way it will validate whether the file is corrupted or not, even while reading it will again compute the checksum, and then it will compare with the checksum that is computed at the time of write, and if both the checksums matches, that means your file is not corrupted. So checksum is the mechanism which is used to confirm that your files are not corrupted. So you will see these checksums for almost all the files in HDFS. Even at your block level, there will be checksum files, and that is how Hadoop ensures data integrity. Okay. So coming back to checkpoint, I have been referring that 1 hour for each checkpoint. So again, there are parameters which will determine how frequently the checksum should happen, checkpoint should happen. Let me search. Yeah, this is the one. So by default, it is either 1 hour, and also it depends upon the file size. It is 16 MB. So if your edit log is whichever happens first. So if your edit log size reaches to 16 MB under 1 hour, even then the checkpoint happens. Or if there are not many changes, and if it reaches 2 MB or 3 MB within that 1 hour, even then checkpoint happens. So the checkpoint is given by 2 parameters, one based upon the size and the other one based upon the time. Whichever happens first, checkpoint will happen. So if you are reaching the 16 MB threshold every 5 minutes, then there will be a checkpoint every 5 minutes. And if it happens only every 1 minute, checkpoint will happen 1 minute, which is not a good sign. In that case, you can increase the size going to these parameters or decrease the time if you feel that 1 hour is too much for the checkpoints. Okay. Yeah, it is possible that your name node can go out of capacity, but let's say you have 128 GB RAM, so you can store hundreds of petabytes of data. If the file size is more than the block size, you can store tens to hundreds of petabytes of data. It all depends upon how many entries can be made in that 128 GB. Even with 4,000, 5,000 nodes cluster with tens of petabytes of data, still your name node can support with 128 GB RAM. So it all depends upon how much you can store in the memory. So depending upon the data you are storing in the cluster, you have to plan your name node configuration. And the primary thing for your name node configuration is memory. Okay, and in very large clusters, you can actually load balance. That is called as HDFS federation, which is not typical and it is out of scope of this course. But just remember that you can use something called HDFS federation, where you will have multiple name nodes, which supports multiple namespaces in a very large cluster. So you can add more and more name nodes and HDFS federation. Let me type. You can go through it theoretically. It is not very important. Okay, that is about checkpoint. Now, who does this checkpoint? So this merging the edit logs into FS images at regular intervals is resource intensive, and to make it fast, you need to do it in memory. Okay, and it has to be done as fast as possible. So if you start using your name node to do so, there can be contention for the resources, for the actual metadata, and for the checkpoints. So to overcome that, they introduce another daemon process called secondary name node. And in a typical production cluster, the secondary name node will be running on a different node in the cluster. In this case, we have configured. Let me go to home and click on HDFS. So we have one name node and one secondary name node, and if you click on that, our secondary name node is in 503. So I am trying to simulate the actual production-like scenario, where your secondary name node will be running on a different node. And now let us go to that node and see what is going on there. New window basic. Okay. So even for that, you can go to configuration, click on service configuration. So in this, it is showing DFS SNN as the name node checkpoint directory. Okay, so you have to use that CD DFS SNN and LSLTR, and you can run find command here to see the structure of files. So if you see, the file names on name node and secondary name node are same. Only difference is the directory structure. So here also you have 593 as the FS image, and there is no 600 here. I'm not sure why there is no 600 here. And if you go to here, you have 593 here as well. So this secondary name node will actually do that checkpoint at regular intervals. So what happens is the secondary name node will copy, it will do a secure copy from the name node, the location DFSNN. So, so this is on name node, and we are on directory DFSNN. And from this location, the daemon process will communicate behind the scenes. So if you run, let me log in back again. So if you run ps-fu HDFS, because HDFS is the OS user which will be owning the daemon process that are related to HDFS. If you run ps-fu HDFS, okay, ps-ef grep name node. So this is the backend process, okay, which is running on our name node, which is 502. Now, if you run the same command here, grep secondary, or you can even give name node. Okay, and the process that is running here is proc_secondary name node. So these two daemon processes will communicate behind the scenes, and this one will actually copy the previous copy of FS image and edit logs, and then secondary name node will create the new FS image, and it will copy back to name node immediately. So once the latest copy of FS image is created, it will immediately copy to the name node. So the secondary name node will act like a helper for your name node to do checkpoints at the regular intervals. Whenever those size and hour thresholds, time thresholds reach, secondary name node will take care of doing the checkpoint to merge the to take the last copy of FS image and latest edit log and create new FS image and copy back to name node. It is not a backup; it is helper. You should term it as helper. It is not a failover. It is not load balance. It will just help to do those checkpoints at regular intervals. That's it. The reason is if you deploy both name node and secondary name node, which does the checkpoints on the same server, you need double the capacity on that. Now by delegating it to a different server, you are offloading the work to someone else. You are delegating the work to someone else, and your name node will be more stable than doing the checkpoints on the name node itself. Okay, it is just a helper class, helper process. So there is no concept of backups here, which is typical in a traditional database world. In HDFS, you hardly do backups. Only at the time of major upgrades, you might have to do the backups, and that I will talk to you about later. Yeah, as I mentioned to you earlier, to checkpoint the edit log and FS image at regular intervals. That is the real use of secondary name node. So that in case if your name node goes down, the FS image and edit log will be used to restore and recovery by the name node. Secondary name node will not do the restore and recovery. It will just do the checkpoints at regular intervals and create the FS images, the latest snapshot of your name node as an FS image, and those if name node goes down, those can be used to restore and recover as soon as possible. So the use of secondary name node is just to do the checkpoint and create FS images at regular intervals, so that your restore and recovery is as fast as possible in case your name node goes down. So this is what I put it here. It's a helper process which merges latest edit log with last snapshot FS image and create new one. That's it. There is nothing else it will do. Yeah, you might be feeling that we are wasting one server and just to do that work. But we are talking about commodity hardware, which is which ranges between $5,000 to $15,000. When it compared to enterprise hardware, it is not very expensive. and the resources that are required by secondary name node will be same as your name node. Okay, now we will talk about important configuration parameters. Which daemon process you are talking about? Are you talking about name node or secondary name node? Yeah. So if it dies after the checkpoint, then you have the latest version of FS image. But if you think from the name node perspective, you already have the previous version of FS image. So you can use that to restore and then apply the edit log from there. It will just take few more minutes and then applying the latest FS image. That's why it is creating multiple copies of FS image. But if you are confident that secondary name node already have done the job, and if, by copying the FS image, you can save time, you can definitely copy this FS image to name nodes, and you can take care of it from there. But by default, you will not be doing all those things. What you need to do is you just have to start the name node in safe mode, or even if you start it and if it is after a crash, it will start in name node, start in safe mode. Safe mode is nothing but that it is actually building the in-memory metadata behind the scenes. So whenever you start your name node, it will start in the safe mode, and it will figure out which FS image has to be restored and which edit logs have to be used for recovery. You will not be doing that job. Your responsibility is just to make sure that your name node started in safe mode, and if it starts safe mode, if it is started in safe mode, then automatically the restore and recovery happens without manual intervention. But it will take time to for the restore and recovery to happen. On a large cluster, it can take somewhere between 10 minutes to a couple of hours for the restore and recovery on very large clusters. Okay, now we will talk about important parameters in the HDFS. I have shown you the name node IP address, block size, and replication factor in the past. And today I have shown you the directories for FS image and edit logs. And also I have shown you data node directories and also name node directories. I will talk about IPs and ports now, but you can use this slide as reference for all the important parameters. Okay, so most of the stuff I have already shown. I will recap on all the parameters once, and then we will talk about the HTTP address parameters and see the significance of them again. It is very important. If you try for certification, there might be some questions on these port numbers. So there will be direct questions on most of these topics. Okay. So the most important parameter is fs.defaultFS in the old convention, and in the new convention it is called as fs.defaultName, and it is part of coresite.xml, and it will have the IP address of your name node, and the default port number on which your name node runs is 8020. So the process which I have shown previously here, this process runs on port number 8020. Okay, and yeah, this is the most important parameter. And if you deploy plain vanilla Hadoop from Apache on a cluster, the only parameter that is mandatory, unless it runs in a local mode, is the default FS. All others are optional, and there are defaults defined for them, and it will take those defaults. But you have to specify what the name node is. If you don't have to specify what the name node is, then the cluster will not know how to work. So this is the most important parameter in Hadoop. The first one, and there can be direct questions if you go for a certification. Okay, and if you use the high availability configuration, it will look a little bit different, which we'll see later. And then this DFS.block size will determine the block size into which the file has to be distributed. The one important thing is if the file size is 200 MB, the first block will be 128 MB and the second block will be 72 MB. So first it will assign as much block, it will fill the complete block size, and the last block will be typically smaller than your block size. And there can be certification questions, or even in interest, people might ask how the files will be distributed. They might give a scenario where you have to copy 200 MB file, where block size is 128 MB, and they might ask whether it will create 200 MB blocks or 128 MB and 72 MB. The answer is the first block will be 128 MB and the second block is 72 MB. And the replication factor is for fault tolerance, and it is by default 3. I will come back to the HTTP addresses, these two parameters in a moment. And then I have shown you the DFS.name directory. It is the location on the name node where your FS image and read clock will be stored. And DFS.data is the location where the blocks, when the file like deck, which is logical in HDFS, is distributed into multiple blocks and stored physically. These are the locations on data nodes which will have those files physically, or blocks physically. And the checkpoint directories are for secondary name nodes. And on secondary name node, you will see those directory, and again you will see FS image and read clocks in that location. And then this is the checkpoint period, which will be done by secondary name nodes, which is 1 hour. And there is one for size, and the other one is also one for number of transactions. So in this case, if there are 1 million transactions, even then the checkpoint might happen, even though it might not have reached 16 MB file size or 1 hour time period. Still, if the checkpoint transactions are 1 million, even that, whichever happens earlier, triggers the checkpoint. Okay, now coming back to name node HTTP address and data node HTTP address. So name node HTTP address listens on 50070, and data node HTTP address listens on 50075. Okay, so why we have to specify 0000 is because there are many data nodes in the cluster, and we are telling the framework that all the data nodes should start the data node web UI on port number 50075. That is the reason why we have 0000 as IP address, but data node HTTP address. And why we have 500, even we will have only one name node typically. Then why we are having 0000 as IP address instead of actual physical IP address is typically your name node will have both public IP and private IP. And if you want to access your name node web UI using multiple IP addresses, then you have to specify 0000. Otherwise, you might run into some not found issues if you only configure your name node HTTP address on a private IP, and if you try to access it using public IP, then you might run into issue. So now we will see the name node web UI and also data node web UI. Okay, for name node web UI, you have to give the name node IP address. In this case, name node IP address is novysync CDH 502 and 50070 is the port number. Okay, and when you give the port number, it will give the name node web UI. And whether you are using Cloudera or Hortonworks or any other distribution or plain vanilla Hadoop, whenever the name node is started, it will start the web server listening on port number 50070. So irrespective of the distribution, you can access this web page, and this is more than enough to understand your cluster. You don't need to have, as a developer, you don't need to have, if you are a developer, you don't need to have access to Cloudera Manager. Or if you are an admin, you don't need to give the access to Cloudera access for Cloudera Manager to developers. You just give this IP address and port number, and developers should be able to understand the cluster and see the health status and all those things. So typically we will give this access to the developers, not the Cloudera manager access. Okay, and if you click on data nodes, it will list all the data nodes that are running on the cluster. I have shown this in the last class as well. All the details are self-explanatory. You can explore, and if you have any questions, you can ask me. And then snapshot, if you create snapshots on your data, like backups of your data for major updates and all, I think it will show snapshots here. And startup progress is how, I mean, if the server is started, if you want to see the progress, you can look at here. And then most important stuff is the utilities. You have two things: browse the file system. You can click the browse the file system, and you can browse through your file system. And we have copied a test.txt file as part of the last class, which is gigabytes, and you can see that here. Okay, and I will copy it to 2 GB file in a moment here, and I will show you how it looks like as well. Okay, now let us go to the data node web UI. So on data node web UI listens on port number 50075, and all the data nodes will have web server running listening on port number 50075. So you can give the IP address and then 50075. I have to give HTTP in the beginning. And you can see your data node. As there are no files, I think it is not showing up anything here. Now let me copy a file. Okay. So any questions so far while copying the file? Okay, I'm copying So I'm copying the file. Once I copy this zipped file, I will unzip it and then I will copy to HDFS. Okay, now let's fetch HD user at we sync CDH 502 LSLTR. I am unzipping it. The reason why I zip is to copy 2 GB file, it will take a long time. So I created a zipped file on my PC. I copied it. Now I am unzipping it before actually copying it to HDFS. Okay, it is unzipped. And if I do LSLTR, you can see the file. It is 2 GB file, and I'm copying it. It will go to, even if I do not specify the path, it will go to the same location, which is user HD user. I don't want to specify the path. So now the file is being copied. And one thing you need to remember is while the file is being copied, it will actually copy sequentially. So it will first, when you actually run the command, it will be executing Java code behind the scenes. So wherever you are running the command from will act as a client, and that client will talk to name nodes, and it will determine on what all data nodes data needs to be copied, and then it will copy one block after the other. So it will first split the first block and then copy to a node, and then it will start copying the second, and it will start copying the third, so on. So in that process, let's say you tried reading the file in another session after the 4 blocks are copied. you can still read that file even though the copying is not completed completely. Still, you can read the file up to the point the file is copied. Okay, and there can be a question in certification. That's why I'm talking about it. So the question could be like this: what happens if someone tries to read the file while it is being written? Can you still read the file, or it will error out? And the answer is you can still read the file until until the point it has copied. Okay. Now the file is copied. Now let us refresh the data node. Yeah, so if that is the case, yes, it will revert back 4 blocks. That is right. So let us see the file now. First, go to our name node, click on browse the file system, and you can go to user, entity user, and you can see this large deck, and you can click on that. And there is a copy on 509. And the reason it has created 4 copies is, if you remember, in the last class, we have increased the replication factor to 4. By default, it is 3. But to demonstrate how you can update the parameters in the configuration files using Cloudera Manager, I have used something called saveval, and I have increased the replication factor to 4. And now you can see 4 copies of it. Okay. And here, if you, that is right. That is right. So if you go back to your HDFS, and if you click on back, and if you click on data node, it is showing the capacity as approximately 1, 2, 3, 4, 5, 6, 7, 8. So 8 into 50 GB. So we have 400 GB storage, total storage. But the capacity is only 100 GB because we have replication factor as 4. And as I mentioned to you earlier, all these parameters, unless they are defined as final, you can customize it at runtime. So you cannot actually determine your capacity of your cluster because it can change depending upon how you want to copy the files. But if you want to baseline based upon your replication factor, at this time the capacity of cluster is only 100 GB, even though we have 400 GB storage because of the replication factor. Okay. So I'm not sure why it is not showing up anything in the data node. Okay, I will come back to that data node here. And under utilities, there is something called logs also. You can click on the logs, and it will actually give you the name node logs, what is happening in there. So this is the one which is the most important log, which is having name node in between. So for data node, it will be having the data node log. Actually, here also it should show the logs. I'm not sure why it is not showing up the logs. Let me close this session. And now let me try. Now we sync. Yeah, actually it should show logs and all here as well. I'm not sure why it is not showing up. Yeah, we can see the name node log here. And this is the most important log. You can click on this and see what is going on in our name node. And if you want to look at in the file system, you have to log into your name node, and then under cd/var/log, there will be a directory called Hadoop HDFS, and this is the default location for when you are using Cloudera. I think you can override it again by using parameters. So in this case, if you go back to Cloudera Manager, and if you search for log.dar, it will actually give the location where the logs will go to. So this is the location which is defined by default by Cloudera. In Apache Hadoop, it might be different. I think it is just varlog HDFS unless you override this file. So you need to understand that the relevance of parameter files, and most of the things are driven by parameter files. It is not only with respect to Hadoop. You take any software, parameter files are the ones which will determine how how the processor should run, how much memory should be given, etc. Even in case of Oracle, we have something called init.lla or SP file or P file. In case of Hadoop ecosystem, most of the parameter files are XML files, but the concepts are same. Concept and importance of the parameter files are same. So any questions so far? Okay. So verify logs and browse the file system. Now let us run the. I have already shown you the relevance of HDFS FS6 command. We will again run that here. You can run from any node in the cluster, even from the gateway. So far I have been doing all the things from the name node. Let me go back to gateway node. Okay, and now if you run HDFS FSCK, user HD user large deck.txt. And one more thing you need to remember is for some commands, relative paths will not work. So for example, when I actually run Hadoop put command, I have given a relative path. I didn't use any path, and the file is copied to user and the directory with OS user name. That is called as relative path. So for some commands, the relative path will not work. So immediately what you have to do is you have to give the absolute path. So HDFS FSCK is one of those commands where relative path does not work. So if I just give large deck.txt and if I try to get some information like files, blocks, and location, it failed because it could not find. But when you run Hadoop FS LS, and if you do large deck.txt, as you logged in as the SD user, as you are logged in as SD user, it will by default look at the /user and /SD user, and when you run this command, it will return the details of the file. But when you run the command like HDFS FSCK, it only understands the full path or absolute path. So when you run with the relative path, it will not work. So now let me go back to HDFS FSCK. So whenever you want to see do some things on the files, and if the relative path does not work, first make sure to use absolute path and then start troubleshooting the issue. /user /SD user, and when I hit enter, now it gives the details of my file. Okay, the file name is the file name is large.txt. It is of 2 GB size. There are 17 blocks, and each block replication factor is 4. So it is copied onto 4 data nodes in the cluster. Okay, so that is about HDFS. So we understand that the HDFS FSCK command, it helps you to get the files, the association between the file with blocks and locations, and also you can understand how the files are distributed physically. Okay, now understanding how to command line interface. I hope you already have some knowledge on that. There are 2 commands. Actually, there are multiple commands for Hadoop. For each tool, there is a command line interface. So for Hadoop, it is Hadoop, in parallel there is HDFS also. For map rate, there is a map rate, and also similarly there is a yarn command also. And if you want to run Hive, there is a Hive command line. Let me kill it. If you want to run pig, there is a pig command line. If you want to do scoop, there is a scoop command line. So for almost every tool, there is a command line interface. Okay, and even for Hadoop, when you actually type Hadoop, there are sub commands under that. So far we have seen FS. FS stands for file system. And to submit the jobs, we will use jobs. So once we set up MapReduce today, we will try to run some MapReduce programs, and we will use this jar command for that. And then there is the dist.cp command. Dist.cp is it uses MapReduce based copy. Dist.cp means distributed copy. So if you want to copy files from one Hadoop cluster into another Hadoop cluster, so source URL to destination URL, both URLs related to Hadoop clusters, it will run a MapReduce based copy process, and it will copy the files as soon as possible. And dist.cp is typically used to back up in case of major upgrades. Okay. Similarly, there are a few other commands also under Hadoop. For now, as we are talking about HDFS, which is related to file system, Hadoop FS is the most important command. Similarly, there is a command line utility called HDFS, which is more latest, and it has a lot more options than Hadoop, and it will be typically used by admins. Most of the commands under HDFS are typically used by admins, and DFS is for file system. Okay. So if you first let us see the admin commands. We have seen SSTK to get the file system details, and if you want to format your name node, you can run HDFS name node format, and it will format the file system. Everything will be gone. Similarly, you can restart the process, name node, secondary name nodes, and all those things using the command line. But when you use the Cloudera manager, you go to the service, and if you click on the small square on the right side of the service HDFS, there are options to start and stop, restart, rolling, restart, and all those things. So you can use these ones directly, and behind the scenes, it will run these commands to stop or start. Okay, and typically when you are using the monitoring tools like Cloudera Manager, you will not restart from the command line, but at the same time you need to be aware of them as well, because there can be a scenario where your Cloudera Manager is down, and still you have to support the cluster behind the doors of Cloudera Manager. And if your Cloudera Manager is not accessible, then you should have idea about the command line and to support the cluster. Okay, so running these commands are important. I will come back to that. So under HDFS, there are multiple sub-commands, and except DFS, almost all the other commands are related to administrative tasks. Okay, and DFS is for file system. Okay, so if you want to see the list of commands under HDFS DFS, you just type HDFS DFS and hit enter. It internally translates into Hadoop FS. So Hadoop HDFS DFS is nothing but alias to Hadoop FS. Both are same, and you will see the same options if you type Hadoop FS or HDFS DFS. Both are same literally. And there are plenty of commands under this, and most of them are self-explanatory. I will highly recommend you to practice. If you are from Linux background, you will learn these things pretty quickly, and the syntax looks similar, but you need to understand subtle differences. You will not have all the features that are available in Linux or Unix, but the command syntax might be same, but options might be limited. Okay. For example, if you look at LS, when it comes to Hadoop FS LS, there are only 3 options. one for recursive. I think -D is for directories. I'm not sure about H. There are only 3 options. But if you think about Linux or Unix LS, there are n number of options. So even though the syntax is similar, there is a lot. They are significantly different. Just to make it intuitive, and they use similar syntax for the Hadoop FS commands. Okay. So these are some of the important commands. mkdir is to make the directory. Copy from local is if you want to copy a file from the local file system into HDFS, you use copy from local. Put is also same, but I think to put can also take from the standard in. So you can run a put command, and if you, I think let me try. I'm not 100% sure. You can do like this: ff minus put, and give the minus, and then you can say user hd user testing.txt. Okay, now if I type and then Hadoop FS ls user hd user, yeah. So there is a file called testing.txt, but I think I hit a wrong command, Control P. That's why it didn't get the data. But Hadoop FS minus put can have an option where you can actually type in from standard in. Whatever you typed on our console can be written to file. That is minus put. Whereas copy from local is almost same as put, but you don't have this option. It is just to copy the files. Okay, copy to local is to get the files from HDFS into local file system. Get is the counterpart of it, and MV is to move from one HDFS location to another HDFS location. And there are options like move from local and move to local as well. So if you want to just move files from your local file system HDFS, you can run move from local. But MV is to move from one HDFS location to another HDFS location. Similarly, there is a CP command to copy file from one HDFS location to another HDFS location, and cat is to write to standard out from the file. So you can give Hadoop FS minus cat and give the file name. You will get whatever is written to the whatever is in the file in the standard out. Tail is just to view the last few lines. Let me demonstrate tail. Hadoop FS tail, and you can use user hd user large deck.txt, and it will display only a few lines, whereas cat will display the entire file, which is not practical for very large files. And there are many more commands which I have shown there. They are pretty much self-explanatory. Explore them, and if you have any questions, let me know. Okay, before getting into name node high availability, do you have any questions on either name node or secondary name node, or how data will be stored in the file system, or any other important concepts? Yes, it's the right timing. So we'll take break for 10 minutes. Now it is 7:55, so we'll catch up at 8:05. Okay, and I will be stopping this recording because we'll be starting on a new topic after this, which is very important: HDFS name node high availability. So we'll catch up at 8:05.